All right, so next talk will be by Soham Dasgupta, who is Oracle ACE Associate and Java expert at Capgemini. He will give his talk about the GraphQL-ifying your APIs. So enjoy the ride.
Jij bent aan zet. Welke stappen zet jij voor de toekomst? Blijf je op bekend terrein? Of ben je een pionier? Welke toekomst creëer jij? Capgemini. Get the future you want.
Welcome everyone. Let me share my screen. Okay, so today I'm going to talk about how to GraphQL-ify your APIs. I have my second screen being shared, so if I'm looking that side, then yeah, I'm looking at my presentation and the things that I'm going to share. I have a couple of polls inside the talk, so hopefully we'll have some kind of interaction during the session as well. So without further ado, who am I? I am Soham. I work for Capgemini Netherlands. I'm an ACE associate. I'm a tech enthusiast. Anything comes up new, I rightly jump into it. I speak, I blog. You can find me in all social media, the technical ones. I come from a very beautiful city of India, Kolkata. So this is not Taj Mahal. This is Victoria Memorial, if you know. And I live in another beautiful city, Utrecht. I do miss the outside sitting and having a beer on the sun though, but hopefully that's coming soon. So that's over me. What I'm going to talk about today is GraphQL, what it is, what are the different aspects of a GraphQL, how do we create a GraphQL API in Spring Boot, and what are the different libraries available at this point of time to do that. And I'll do a little bit of comparison between all these three libraries. So what's the plus point, what's the minus point, and at the end, I would give my subjective opinion on which one should be better and how you can use it actually. So what is GraphQL? It is a little bit different than the REST API that we are used to, or even the SOAP that we are used to. GraphQL, I see it as an aggregator. So it's a query language for the API, which will do the runtime execution of your queries inside the GraphQL server. It is totally backed by your existing code. So you do not need to rewrite all of your API backend code just to have GraphQL enabled for some of your APIs. I'll show you a brief comparison between a simple Spring Boot application and how that we implement in three different libraries using GraphQL. It is actually introduced by Facebook to get around the common problems with REST. So it's for REST, if you have an API or an endpoint, it's all or nothing. So you ask for something and you get everything, even though you don't want it. And Facebook wanted that to be minimized. Not only the data that is being retrieved, but also the server, which is actually working for you to get that data. It was open sourced by Facebook in 2015. Since then, a lot has happened. I mean, 2018, I remember being in a talk at DevOps UK. One of our very good ex-colleague, Louis, was talking about GraphQL and how you can use it. And the code base he used was Node.js. And that time, there was only one library to use. And now there are three. Netflix have come up with a new library last November. So it's quite interesting what's happening in this space. Before we go ahead, let me tell you very clearly, this has nothing to do with GraphDB. Although you can write a GraphQL API on top of your GraphDB, but your GraphDB is not equal to GraphQL. It is also not a replacement for your REST. They both can actually live together. REST has its own purpose. GraphQL has its own purpose. I hope at the end of this session, I can give you a bit of a overview on when to use what. And yeah, it is not going to solve your API design issues magically. They will be flawed even if you implement GraphQL on top of your all APIs. So what it is exactly, in a GraphQL, we define a schema. The schema is a bunch of queries which you can do, and a bunch of mutation which you can actually apply to those objects. So mutation, for example, the CRUD operation. So you can do a create, update, delete. And queries basically get the data back from your backend, be it a database, be it other APIs, whatever. And this schema you define based on different objects. So in the screen you see I have 4 different queries for services and providers. And I have defined 2 objects. One is a provider, one is a service. And a provider has a list of services, which is defined as an array. And a service has a provider. So it's a one-to-many mapping between provider and services. And when you query that, you query with what you need. So even though provider gives you ID, name, description, maybe for your front end or the client that you're writing, you only need the provider name. And you actually get that back. I'm going to show you some example of how to call them. So this is GraphQL. GraphQL is a nice, web-driven interface that GraphQL provides to write your query nicely. So it gives you the auto completion option. So I am going to write a query to get, say, services by ID for the ID 12, and I only want name and description, for example. And if I run that, I get it back. Nothing more, nothing less. Even though the service has a many-to-one mapping to provider, in the back end, I never query it unless I ask for it. And for example, if I also want the provider here and maybe only the ID of a provider, I can also do that. For example, I can combine multiple services by multiple queries. So for example, I'm going to do a provider by ID, for example, with an ID 4. I think there is a 4 ID exists, and I only want the description over here. And if I run this, I get it back. If you realize, I actually ran 2 queries in one request. Quite powerful aspects of GraphQL. In a normal REST scenario, you actually had to do 2 API calls to get this back. But yeah, for GraphQL, this is a quite powerful example. You can also do, like, for example, in your UI, you have a right side card, right card, and you have a left card. And both are showing some sort of service information on your UI, and you want to get those back. And you actually can fragment this queries inside GraphQL. So you can identify, this is my call for the right card layout, and this is the query for my left card layout. If you see, I am actually querying the similar data structure back. So what I can actually do is make this a little bit reusable. And let's say card object. And I'm going to define that card object also here. I do need 3 dots though, by the way. And I can define a fragment and I say, this is my definition of the object, and I'm going to use that. And it, voila, gives me the same. Keeps your query quite compact and gives you the reusability when you are actually using this. You might be asking the question, why I'm using GraphQL? Can I do this in Postman, for example? Yes, you can. Postman, either you can actually do a post request or a get. I'm going to show you the post. So it's quite similar, actually. If I just copy paste this whole body in here, I would get the same results back here. So it's a simple query, just like any other REST call you're doing from your client code, be it JavaScript, be it another Java client, or be it some other application. It follows the same properties of doing API call from any other applications. The magic it gives you is do fragmentation, making aliases, reusing different kind of object structure, combining queries, and also making multiple queries in one network call. Let me go back to my presentation. So that's on a very nutshell what GraphQL gives you as a powerful tool to use it. But who is using it, actually? This list on 2018 on that talk was 1/3. And in last 3 years, it has been so much exploded that I could not fit this whole thing inside one slide. I actually needed to make this image so small so that I can just fit it. So it's quite a lot of companies who are using it. But remember, not as a replacement for REST, but as a extra functionality next to your REST APIs, so that you can use it as an aggregator. I also actually tried to see how are the trends. So I checked on Google on GraphQL versus REST versus SOAP. And over the years, REST is actually quite shaky, to be honest. For some reason, SOAP went up before at the beginning of June, the beginning of this year, and GraphQL is coming up. And sooner or later, you will see aggregation of your APIs being handled by GraphQL servers quite a lot. And I also did a research, and I don't know why, because of the in Netherlands, somehow the GraphQL is going up. So I could imagine in Netherlands, people are actually looking into how GraphQL could be done. So what are the different characteristics of GraphQL as such? I see GraphQL as an hierarchical query language. So if you have a very strong hierarchical data model backing your APIs, there could be a reason to look at GraphQL possibilities, because GraphQL gives you this feature of querying what you need, not more than that. So I'm going to talk about later in this session about what is an N+1 problem. But hierarchical problems are when you're querying hierarchical objects, getting over queried is a very common scenario. It's also an aggregator. As I said, if you have multiple backend objects coming from database or other APIs, you can use GraphQL as your aggregator for your front end or your lightweight clients, which will use less network traffic to get all the data required at one call. It is very strongly typed, so you cannot mismatch a request. So you need to follow your schema definition. So once you write a client, use a schema definition to check whether they are perfectly fine or not. It does a validation and a type check out of the box, so you don't need to implement anything on that side. I'm gonna show you in a bit how does it looks like when you actually mistype something. The most amazing feature of GraphQL is evolution without versioning. So we are all quite familiar with when we do API design, there is always a version 1, there is always something in the header or in the URI regarding which version of the API you are using. And sooner or later, when that version changes, you need to also adapt all your APIs according to the new version. In GraphQL, you do it in a different way. So there is no version 1, version 2. You deprecate on a field level. So if in services you want to deprecate the ID property, you just don't return it anymore, and your clients on the down stream will have to adapt slowly to that deprecated attribute. So one of the biggest feature what you can use in there. I already talked about it a bit when I was showing you how to use it in GraphQL interface or in Postman. But yeah, query and mutation gives you the option to ask what you need. You can expand the same query to add more fields to it. You can use aliases to identify what query is actually used for which section of your client. You can also fragment it, so you can define your own custom objects without reusing it in your query every time when you're invoking it from your client. The GraphQL on the back end provides a huge set of data types, so integer, string, boolean, and float. You can also use lists. So lists are being actually managed by the array notation. And the exclamation tells you this is a non-nullable field. You can also use interfaces. The interface is a little bit different than the interface we are habituated in Java. Here, the interface is mostly to define the common fields so that you can use this in multiple places in the schema definition. It also defines the input type. So in a mutation, for example, you want to receive an object which has a ID, name, and description. You can define an input type so that you can reuse that more in different places. But all good is not so it's not always the good side of the GraphQL. What I felt from it's a very subjective opinion, although what I felt from GraphQL is lacking a little bit from the level of maturity is the biggest problem is file upload. GraphQL is, to be honest, should not be used for file upload options. But if your architecture only provides GraphQL, then file upload with GraphQL is a little bit of gray zone, to be honest. It also have a little bit of caching complexity. What I mean by this is you need to implement your own caching inside your service or repository layer, or the APIs that you're calling from the backend will have to involve in the caching mechanism. Although the newest framework from Netflix actually helps you a little bit on caching, but that's on a different aspect of the caching itself. It also has quite a lot of, I would say, gray area on the N+1 query related problems. I'm going to show you what I mean by this and to give you a better understanding. And I felt the community presence in compared to REST and so is a little bit low, but yeah, it's only released in 2015. So if we give it another few years, this will grow. And since now we have 3 different libraries to use from, I have a better hope in a year or so, this will also increase a lot. So lots of basic theory, but I do want to use to see how much you actually, so I'm going to use a poll, and I hopefully you see the poll also in your screen. Would be nice to know how many of you actually coded in GraphQL. Wow, this makes my life a little bit easier. So I'm going to close the poll a bit, but don't worry. It is not that hard actually to write a GraphQL based API. I'm going to show you how, at least some of the mechanism. So this is my demo Spring Boot application. I have a in-memory H2 database which has a provider to services one-to-many relationship. I have a JPA repository. I have a service class with service annotation, and I have a controller which is actually serving all these endpoints. So if you look my Swagger, it looks like this. And if I call all the services, I do get services with the providers connected to it. So there is everything or nothing kind of a scenario. So the first library I'm going to talk about is GraphQL Java. This is the oldest library for GraphQL, coding GraphQL. Although if you have to use it in Spring Boot, you do need to have another dependency added, which makes your GraphQL server and do all the injections and runtime varying for you. It is quite active. The current version is 16.2, and it was last updated this February. So this is active and open source as well. So it's not really left out, to be honest. So what changes in that application of the normal Spring Boot one? So the service, repository, and the H2 remains the same. What changes is we have to replace the controller with a data fetcher, a data loader, some kind of runtime varying, and a GraphQL schema. These all terms looks quite alien to you, but I'll show you the code to make it a little bit easier to understand. So what we do is we map every query to a method. So think of it, if somebody asks for services, the framework will invoke this method to give it back. If somebody invokes a service by ID, it'll invoke this. It also gives you the field level mapping. As I was saying, it only fetches the things that you want. So even if I have a foreign key to provider inside my service, I only will fetch if the provider is being called in my API or the query. And that is also what you do in the mapping. And once you have all this mapping, you basically create the runtime varying, and you create a GraphQL schema object, and you expose that. And once you expose that, your GraphQL service is up and running, and you can actually use it straight away. Then what are these data fetcher and data loader? I'll come to it in a bit when I'm going to compare the libraries in detail. So going back, the second library is actually the GraphQL Java Kickstart. I don't think I have much time left, but I'm going to rush through it a bit. GraphQL Java Kickstart. It's also quite active. The last update was in June 21. The only difference is if you are willing to use this in Spring Boot, there's only one dependency you have to inject. They also provide you a web client, which you can use to call GraphQL endpoints easily. What changes here? They take out some of the boilerplate code. So as I showed you, the runtime varying was basically string to map to a method, which is being taken out by this implementation, and they create resolvers, which are more or less a bit of a typed implementation of the query, mutation, and the field level. You still have a data registry, which has to be registered via a context, servlet context. The rest remains the same. And if I show you the code, basically you define a component which implements a specific interface, and all of your methods should match the name of your query schema. So if I have a services, I need to have a method which is services and returning a list of service back. And same for all other properties. So if I have a mutation CRUD operation, I would implement some other interface which will have the same name as the mutation requires it to be. This loosely implements in a way of inheritance, and take out all the boilerplate code which is required in this. So basically all of this I wrote just to make the server up and running, which is a little bit taken out by the Kickstart library. And the last one is the DGS framework. This is the latest. This is open source by Netflix last November, I think. And it is last updated on April. So every month or every 2 weeks, they're releasing a new version of it because this is so new, and the community is finding different kind of implementation corners which needs to be implemented by Netflix, and it's quite a easy framework to work with as well. So it makes life a little bit easier. So you define DGS data and DGS data loader, and that's it. And the rest is basically mapped. And how does it look like? It looks like this basically. So if I need to define a component, which is a DGS component, and then I defined this is a query, and for the services, please invoke this method. So it is very annotation driven, injection based implementation. Takes out a lot of boilerplate code, to be honest, and quite easy to use to be for a startup. So now you've seen 3 different libraries, but what is better? I did a comparison on a few different aspects of it, not everything. I didn't you will not find any comparison of pagination or how to implement it in 3 libraries, but the basics are covered. So what is a data fetcher? Data fetcher is basically the piece of code that gives you back the data. Think of it like your repository method or your endpoint, which you invoke to get the data back. For GraphQL Java, you actually define all those as a string to method mapping. For a kickstart, you actually implement interface and then define your methods, and your methods name has to be same as your schema definition. And for DGS, you define a DGS component, and within the DGS component, you define your DGS data. Anyway, I also talked about what is a data loader. The data loader is basically which is doing your n+1 issue. I'm talking about this n+1 issue quite a lot, but what is it actually? Let me show you in the logs. So if I query services and I have a provider for each services, the number of query that will be run is actually the number of services plus 1. So 1 query for getting all the services, and every service, it will get the provider. There is an easy way to solve this in the JP implementation, but when you are aggregating something using GraphQL, it is not so easy. And that's where come the data loader. The data loader is a specific implementation for GraphQL itself. I'm going to show you inside the GraphQL Java library, which is, I think, this one. So GraphQL Java library, you basically create a method which will, so for this example, I use the in-memory H2. And I have declared a method which can take a list of IDs and run 1 query to give me back all the results at the end. And I use this method inside my service, which basically takes also a list of IDs and return this list back. But if I show you the usages, I also define something called a batch loader. There are 2 different types of loader in GraphQL. One is a batch loader, another one is a map loader. Here, I create a computable future which collects all the IDs that needs to be queried, and at the end, invokes the method to load all the queries. So by this way, I am actually minimizing the query to 2 when I'm asking for all the services along with their providers in place from n+1. So all these libraries actually give you the option to define your own data loaders, but they do it in a little bit different way. Some places you have to define a component and register it, and then you can use it. Some places you just need to use an annotation to use it. The mutation is also quite straightforward, like query. You need to define for the GraphQL Java mapping between each other, and for Kickstart, another component with an implementation of a interface. And for DGS, it's basically an annotation on your method. They all do error handling in their own way. Actually, pretty interesting to know. Let's, for example, I mistype attribute. You'll see I still get status 200 OK. So this is a feature of GraphQL where every response you'll get 200 error back, but 200 success back. But the only difference is you get an error object within. So you can handle your error exception handling in your client is pretty tightly coupled with your success follow through. So you don't need to write different code to do different stuff. Your whole object is one. Either you have data or you have error, and you tackle the errors in a different way. And for all these three libraries, it has three different ways of handling it. The client. There's quite a huge issue of writing a GraphQL client, because normally you need to have a client which you need to have an object to invoke using REST client or a FEN client, but that object cannot have everything. So you need to also somehow manage the object creation. I'm going to show you an example application I actually wrote using Mutation client. So if I just read on it, you will see the logs as well. So it reads from a template. So for example, I have a template of service by ID. And depending on what I want, I enable them and query the endpoint. And I only get what I need. So for this example, I'm only getting all the attributes of service, but nothing from the provider. And it actually gets me the stuff which are only related to that. Testing and code generation, DGS provides you a type safe option. You can generate your objects to call your client. So that's a major difference from the previous two applications, previous two libraries, basically. You can use your own objects to write your unit test cases. Other way, the only thing you can do is the service repo layer testing. Last but not least is the runtime memory and image size. Once you start this up, they all quite use a similar kind of memory in a Kubernetes or a Docker environment, and also that Docker image sizes are quite comparable. By the way, they are all built within using OpenJ9, so these might vary what kind of base image you use actually. So what is better? To be honest, I like the DGS quite a lot because it brings down, minimizes your boilerplate code. And it's basically built on the GraphQL Java framework. So everything that this has, DGS framework also has, but with a touch of easiness of use. There's a client available. You can generate your own objects for the client, and it is directly usable within Spring Boot. So my support is for DGS, even though it's quite new. There are quite a lot of Netflix is using this for last year or two within their application itself before released it to everything. So yeah, so my perspective, DGS is a quite nice library to use within Spring Boot. I think I have gone 4 minutes over time. If you have questions, this is the moment to ask. I would also like you guys to invite on our BLD Tech Talks, which happens every month. And the upcoming one is in May 25. You can get all the details in the Capgemini booth or ask any one of us. Thank you.
All right, great talk, Soham. I'm getting some questions in the chat. So Gerard Mulder is asking whether there is also a reactive version of GraphQL.
There is. The web client I showed from the Java Kickstart is actually a reactive client. It uses Webflux under the hood. So you should check it out. I'll post the link as well. Let me see and show. So this is GraphQL. So if you go to this link, there is a client which provided by the Java Kickstart, which is based on reactive.
All right, great. I saw also some discussions starting about frameworks in other languages. Some people already shared some .NET frameworks. What do you know how popular GraphQL already is for other languages, say .NET or Python or?
I honestly don't know, but this is a nice bridge to the last slide I was talking about. So last month in April, actually in BLD talks, some of my colleagues talk about GraphQL in Azure and Microsoft space. So I think there is a recording available in YouTube. Please check it out. I think there will be the information that you're looking for should be there. Otherwise, I can connect to the people who actually gave the talk. Oh yeah, Kim, thank you. Yeah. So yes, there are, but I am not aware of it, but there are people who are, so cool. Definitely.
All right, I think, I don't know whether there are any more questions from the audience that they want to ask right now. We kind of went over all the questions they had so far.
If the questions are over, then this is the slide share of all the slides that I used. You will also find all the code in my GitHub. It's all there. You can check out. You can play around. Yeah. Let me know.
All right. Thanks a lot for the talk, Soham.
No problem.
Really great. Learned a lot.
Je hebt talent. Je hebt idealen. Jij bent aan zet. Welke stappen zet jij voor de toekomst? Blijf je op bekend terrein? Of ben je een pionier? Volg jij anderen? Of word je zelf expert? Blijft het bij idealen? Of maak jij dromen waar? Scoor je zelf? Of win je als team? Welke toekomst creëer jij? Capgemini. Get the future you want.